All right, so this is going to be covering some trig examples. So this is part 3 to the section 4.4 videos. And yeah, I'll do these 4 problems involving trig. And then I'll do another part 4, doing these problems. So the first one, number 29, you're doing the definite integral from sine x minus 7. And the definite integral goes from 0 to pi. All right, so you have to remember your integration rules for the trig functions. And integrating sine, so the derivative of sine is cosine, but the integral of sine is negative cosine. All right, so most people get them mixed up because there's a minus sign when you integrate sine, but when you take the derivative of cosine, it's negative sine. So derivative of sine is positive cosine, but when you integrate sine, it's negative cosine. So this will be equal to, so sine turns into negative cosine, and then you're integrating 7, so that becomes 7x, so minus 7x. And that's going from 0 to pi. All right, because when you integrate any constant, that becomes that constant times the variable. So now I'm going to apply the fundamental theorem. And so I'll have minus cosine of pi, and then minus 7 times pi. All right, that's the f of b part, or the f of pi. Then I subtract out the antiderivative with the lower bound 0. So it's negative cosine of 0, and then minus 7 times 0. Okay, so what is cosine of pi? So cosine of pi is -1. So this is really negative times -1, which is positive 1. And then we have minus 7 pi. And then cosine of 0 is 1. So this is -1. And then 7 times 0 is 0. So just -1. All right. So that's 1 minus 7 pi. And then this becomes plus 1. So we have 2 minus 7 pi. And again, right, we're doing the fundamental theorem of calculus, and fundamental theorem of calculus, just you integrate like f of x dx from a to b. That's equal to capital F of b minus capital F of a. Where capital F is the antiderivative. All right, that's what we've been doing in the previous videos. All right, so that's number 29. The next one is number 31. All right, so you have 1 minus sine squared theta over cosine squared theta. And there's nothing on the integration table that we have for sine squared or cosine squared. So I need to do some rewriting. So I'm going to rewrite first so that we can apply the rules, the integration rules that we already know. So we can apply the known integration rules. All right, so we know from trig, sine squared plus cosine squared equals 1. All right, that's the Pythagorean identity. So therefore, cosine squared theta is 1 minus sine squared theta. So I can rewrite this 1 minus sine squared. That's cosine squared. So I have the integral from 0 to pi over 4. And I'm changing 1 minus sine squared into cosine squared by using the rewritten version of Pythagorean identity. Then the cosine squares divide out, so you just have 1 d theta. Or just d theta. And whenever you integrate a constant, you get that constant times the variable. In this case, our variable integration is theta. So it'll be 1 times theta, which is theta. So this is 1 times theta. And again, that's the same thing as just theta. So we just apply the fundamental theorem. And it's just going to be pi over 4 minus 0. All right, you just plug in the value in for theta. So this is f of pi over 4 minus f of 0. So the answer is pi over 4. All right, so that one, once you rewrote it, it's a really simple integral. And doing the fundamental theorem is just really just plugging it in. All right, so the next one's 33, and you're doing secant squared, and it goes from negative pi over 6 to positive pi over 6. And there's actually, if you go to the integration table, we know the integral of secant squared is tangent. Right, and that's because the derivative of tangent is secant squared. So you pretty much already have our antiderivative. It's just tangent x. And then we just evaluate it in pi over 6 and then negative pi over 6. That's going to be tangent pi over 6 minus tangent of negative pi over 6. And I use the unit circle, and on the unit circle, let's draw a really shitty version of it, but let's say this is pi over 6. And then you have the point, and I believe it should be 1/2 comma square root of 3 over 2. Oh, I have it flipped. It's square root of 3 over 2 comma 1/2. All right, and we know cosine is the x-coordinate, sine is the y-coordinate. At negative pi over 6, that's going clockwise pi over 6. So it's going down pi over 6 in the other direction, which is the same thing as if you go to counterclockwise, the normal way that we would go, and that's 11 pi over 6. So 11 pi over 6 is the same as negative pi over 6. And at that point, is going to be square root of 3 over 2 comma negative 1/2. Since we're in the fourth quadrant, the y-coordinate's negative. All right, and so we know sine, or tangent sine over cosine. So tangent of pi over 6 is sine pi over 6 over cosine pi over 6. Sine of pi over 6 is 1/2. Cosine is square root of 3 over 2. So we know the 2's divide out, so you have 1 over square root of 3. And then you would rationalize that, multiplying top and bottom by square root of 3. And that turns into square root of 3 over 3, right? Because you multiply top and bottom by square root of 3, so that you have the square root sign no longer in the denominator. All right, so tangent of pi over 6 is square root of 3 over 3. Now tangent of negative pi over 6, same as tangent of 11 pi over 6. On the unit circle. Again, that's sine over cosine. And we basically have the same setup, it's just now we have negative 1/2 for sine. So it's negative 1/2 over square root of 3 over 2. Which is going to give us square root of 3 over 3, but it'll have a negative sign. All right, so tangent of negative pi over 6 is negative square root of 3 over 3. All right, so I'll circle that. And then circle that. So this is all sort of just scratch work. I don't need to see this on like a test or anything. If you already know what it is, I break it down into sines and cosines because sometimes I forget, and then I'll just look at reference the unit circle. So tangent of pi over 6 was square root of 3 over 3. And then we have minus, and then tangent of negative pi over 6 is negative square root of 3 over 3. So it's basically square root of 3 over 3 plus square root of 3 over 3. All right, so that's 2 square root of 3 over 3. And all of this down here is scratch work. All right, so that's that question. Next one's 35, and it's from negative pi over 3 to pi over 3 of 4 secant theta tangent theta. All right, and if you go look at the integration table, when you integrate secant tangent, that turns into secant. I guess I'll use different variable because it'll be, we've learned secant x tangent of x turns into secant x. Right, because the derivative of secant is secant tangent. So this will turn into 4 secant theta because we have the 4 that we'd factor out in front, and then we integrate secant tangent, and that's secant. So it'll be 4 secant theta. You're going from negative pi over 3 to pi over 3. And what I like to do is I'll just factor out the 4 in front and just focus on secant theta. So that's going to be 4 times secant pi over 3 minus secant of negative pi over 3. And again, I would reference the unit circle. I know secant is 1 over cosine. And then at theta equal to pi over 3 is the point 1/2 comma square root of 3 over 2. And we know cosine is the x coordinate. So secant of pi over 3 is 1 over cosine of pi over 3. And cosine of pi over 3 is 1/2. So this is 1 divided by 1/2, which is a reciprocal of 1/2, which gives me 2. All right, so I know for secant of pi over 3, that's 2. Secant of negative pi over 3 is 1 over cosine of negative pi over 3. And if you were to look at the unit circle, going pi over 3 that's negative is clockwise. It's equivalent to the counterclockwise amount of going 5 pi over 3. So what I'm saying is if I go counterclockwise or clockwise, negative, that's negative pi over 3. Going in the normal direction counterclockwise, that's 5 pi over 3. So this is really 1 over cosine of 5 pi over 3. And that 5 pi over 3 is also the point, it's 1/2 comma negative square root of 3 over 2. But we only care about cosines, that's the x coordinate. So we get the same thing, it's going to be 2, because we're doing 1 divided by 1/2. So this is 4 times, and it's just 2 minus 2, so it's 4 times 0. All right, because, yeah. So that's going to be 0 is the answer. All right, and that's where I'll stop it for this video and do the other examples in a part 4, but I want to do some trig examples in this one. And all of this scratch work that I'm doing down here, you don't need to do. That's just my way of doing the problem, is I want to reference the unit circle and use what I know as far as identities is converting it to sines and cosines, but it's fine if you just want to go ahead and say it's 4 secant of theta negative pi over 3 to pi over 3, and just pretty much go like this, left to right, like right here. All right, so that's it for this video.